earthquake with the thrust motion, so it lasted long. It's about 1.5 minute long. But then, as expected, because it's a large earthquake, we had a series of aftershocks, and those are significant one, including the largest one, 7.3 in May 12. Again, that create another damage in those areas, and it creates a rupture. It ruptures large area again by itself. So it's the period of earthquakes there for about 2 and 3 months. There are always earthquake there one and another day. So they used to live there with the earthquakes, and where we happen there's also aftershocks. We also experience some aftershocks. And talking about the magnitude here, this is Kathmandu capital city here, and the major earthquake, the first earthquake is there, and then all the areas ruptured, and then second major aftershock is there, 7.3, which is northeast of Kathmandu, again with a similar distance. Talking about the context, or in terms of seismicity, yes, Nepal lies in the plate boundaries between the big plate of Indo-Australian plate, which is very active and moving towards north, it converges with Eurasian plate, which is relatively stable. So there is a collision there that creates earthquake, as we have here in British Columbia. So here is a Pacific plate and North American plate, where we have those. We are expecting large subduction earthquake. It's a similar setting here. Talking about more on seismicity, it's a very active, actively moving. It is a whole continent, that Indian subcontinent is moving with a velocity of 3 to 4 centimeters per year, which is large. That means Nepal and over its east to west boundary of 1,000 kilometers, it loses about a 4 shock of field every year, because it's pushing there and then it's diminishing. It's a very active region. And if we say the past earthquakes, yes, it's a history there. In the last 8 centuries, there are about 8 major earthquakes, exceeding magnitude of 8. So that means, yes, it's earthquake zone. But again, compared with other areas, for those large earthquakes, it's a very high consequent and little bit less frequent, we say, because large earthquake happens every 80 to 120 years. And exactly in 80 years, we had this one, because last one was 1934, killing almost 8,000 people that time. And you can see that whole range of Himalayan range here. You can see the earthquake from 14th century all the way there, and the last one is 1934 here, where the Kathmandu is close by here. And this time earthquake happened again in the same area, little bit filling the gap between this one here, but overlapping with 1833 earthquake rupture area. But still, there is a large area remaining untouched for last 500 to 600 years. So that means it's not the last earthquake. It could happen again, the big one there. And here, just talking about, when we talk about the Nepal geography and demography here, we should know this is a whole country is divided into 75 districts, and out of those 75 districts, 31 districts are affected by earthquake, and out of that, 14 districts are severely affected. And among that, 7 are a large hit in terms of casualty and lots of damage. Kathmandu capital city, not in the very highly affected area, but still, being an economical and cultural capital, it was hit hard by the earthquake. And more casualties are in Sindhu, Palchok, and Golakha district there, where our mission have been there to see the damage and to talk with people there. In terms of consequences, yes. When it comes to casualty, and also with the percentage GDP, it's very high. The economy of Nepal is very small, so even if it is $1.9 billion direct loss, this is a direct loss, it's still 30% of GDP. And in terms of population, yes, 3% of population it is expected that it's going to be poverty just because of this earthquake. And when it comes to population of the size of country, it's as small as 1/5 of BC, but it's as big as Canada in terms of population. It's almost 30 million, 28 million, close to 28 million. It's a very crowded place. That's where if earthquake happens right there, that's the exposure is very high. And you can see that the damage to the infrastructure, the heritage structure there, and damage to concrete buildings. In emergency relief, that was very hard task for emergency responder there because of the topography, because of the nature of the landscape there. It has high mountains, and the earthquake happened in the mountainous, very high mountainous region. So it is so hard to bring all the emergency supplies to the people in the remote area. There are a number of places which don't have any access to road, so all the relief materials should go by airlifted by helicopters. And that is the only means. But still, the resiliency of the system is that the army, the police, and civil servant were there to every village almost within a week. And community itself, they have their own set of mutual help, self-help, and cooperation and trust and confidence building. There is no major secondary human kind of looting or anything that we have seen other parts. It's not there. So it is well resilient within the community system itself, which is good. And just to talk about the airlifted material here, more than 1,100 tons of relief material was airlifted to remote areas. You can think of how much extensive work for relief workers there. And yes, Nepalese army did that, but there is a huge support from international community, and including neighboring countries and all the way from US and also from Canada. You can see some of the foreign agencies, doing their work in the field hospital with the child care in the remote area, which is a Sindhupalchok where we have been. It is one of the hardest hit in the very northern side. There, that is how the hospitals are working. That's a hospital sign there and child care facilities, and absolutely, bare minimum kind of things. And within that we are there after a month, and they maintain that bare minimum kind of things there. You can see that drinking water, and it is written in Nepali. I can read, and it says that this water is just for drinking. Water is not available for anything else. So that is the situation. And here it shows that the community self-help, mutual cooperation practice there. Having a blood donation right in the heritage site, and there's a large influx of people who want to donate blood for the earthquake victims. That was the scene that we have seen, and now we want to go to the building constructions and other damage here.
You hear me? Okay. Thank you, and pleased to be here and have opportunity to share a story from first-hand experience being in an earthquake. This is not the first earthquake I've been to. Been in a few most recent one. Before this was in 2010. I went after the magnitude 8.8 Chile earthquake in Chile, and the scenes I've seen in Chile are very different than the scenes I've seen in Nepal. And the extent of damage, even though it was 8.8 magnitude earthquake, only 520 people died. I visited the damaged area extensively, but it was nothing like Nepal. And also talking about building construction, I just want to say that going after an earthquake, when you go and there are aftershocks, and in fact they have been expecting to see an aftershock magnitude between 6 and 7 once again before they're saying within a 4 months period. So we were after a month and a half, and we could have experienced that one. That didn't happen yet, but we were all staying in a hotel in Kathmandu, and the first thing you think when you go to a hotel in a country that has been so badly affected by an earthquake, saying is the hotel safe? And they have this way of, it's beautiful, at the outside it's heritage building, but inside it is actually more contemporary reinforced concrete building components. And Nepal is one of those countries that you're not sure if you're safer in older building or newer building. So we were all concerned. There were a few other teams that were in the same building, like Doctors Without Borders and some other earthquake teams, so we thought somebody must have looked at it. And we did experience a few aftershocks. One of them was magnitude 4, 6 kilometers away from where we were. It was pretty scary, I can tell you. So I cannot even imagine how it was to be at magnitude 7.8 earthquake. Talking about building construction in Nepal, most of it is, as you can see here, it is information from their census. And the way they classify the census is, you can see cement-based masonry and mud-based masonry. What it all means is just the type of mortar in masonry. It's not that mud-based masonry is all Adobe or mud-based block masonry construction, but it means that they are they're mostly with mud. And so taking that cement-based and mud-based masonry, you can get that 80% of construction is out of masonry, one way or the other, and then 15% is reinforced concrete, those modern buildings that Bishnu will be talking about later, and then wood and bamboo, more traditional construction, 6%. So, so mud-based construction is obviously prevalent. Talking about the damage to this type of buildings, and mud-based masonry, obviously you can see blue lines show complete damage, and this orange or brownish partial damage, you can see prevalent damage in or collapse in mud-based masonry, much less in brick masonry, cement-based masonry, that means more modern masonry construction, and then a little bit in reinforced concrete, much less than either of the masonry construction practices. So that is what we have seen. Talking about practices, what we could see by visiting towns and villages is that most of the urban, in older buildings, in urban or old urban cores, such as if we go to downtown Kathmandu, you can see adobe buildings or brick masonry buildings in the cities. If you go outside and in those hilly areas, these are stone masonry because that's all they have. They have nothing but stone, and that's the major culprit, was the major culprit in the earthquake. And then there's a prevalent trend everywhere where there is cement available and steel to use concrete construction. In most cases, inappropriate and not in a very knowledgeable way. So that is what we could see. And in terms of building codes, before I show you some photographs of damage and explain them, building codes were first introduced in Nepal in 1994 in response to the 1988 earthquake, which Bishnu didn't show on that slide, sorry, because it was not as strong. That slide showed magnitude 7 and higher. This was 6.9, however, it caused the collapse of 20,000 buildings, and it turned out that concrete buildings performed better, and therefore whoever could abandon masonry buildings or build new building, they would use concrete construction without proper guidance or codes. So in 1994 they introduced codes, and they were mostly introduced by, with the help of foreign experts and United Nations, and they were never renewed or updated until 2015. Also, even more importantly, they were not implemented. They were not enforced in most cases. So by looking at the concrete building, it doesn't mean it was done according to a code. You only know it is concrete building, and because it was already constructed, you also don't know how it was constructed. So it's lots of unknowns and very difficult to assess performance, unlike Chile, where you know if the building was done according to the code, you could know, you know what it was in it. So, so what we could see mostly in terms of performance of masonry construction versus concrete construction is that we could see that we could see lots of scenes where concrete buildings with this stood and then masonry was damaged or collapsed as a typical scene, and then also in the rural areas where we went outside Kathmandu, this was typical scene, and this is what photo that we took, but there were much more dramatic photos. It's complete devastation of the villages. You could just see piles of masonry of stones instead of the buildings or the houses. So it's horrible. So masonry buildings, as I said, stone masonry, I will talk about that. Most common in the rural areas, a little bit about brick masonry. and concrete block masonry less common, and Adobe, and I'll not be talking about that because most of them were collapsed actually. So in terms of stone masonry housing, this was the most prevalent rural construction practice in Nepal. Typically 1 or 2 story buildings. You can see that how they look like. This is a typical well-built stone masonry building actually, and it survived the earthquake obviously. And you can see pitched roofs, light roofs, which is good. They have some metal roofing usually, and they have timber floors, which are here. I think I should keep this speaking to it somehow. The voice is not clear all the time. So this is a timber floor, as you can see. So they don't have too much of a diaphragm action, which means something to earthquake engineers. And inside, you can see inside the floor, you can see the planks and system. So we could see both good and bad performance of stone masonry buildings. One would think with this type of construction, you could see all collapse, but we have also seen a good performance. And for example, this is on the left side, you can see a building which they're in the same village. They were very close to the epicenter of the second earthquake, and the one that had some timber elements that were like ring beams around, which was a traditional practice for many years, it performed quite fine, and we have seen other buildings of that, whereas the others, which were built more poorly without those elements, collapsed or were very badly damaged. So, so taking us back home, we do have similar stone masonry buildings. They look much nicer though, and more monumental, like Parliament building in Ottawa. But when you look inside, I was working a bit on reviewing a part of the rehabilitation project. I don't know if you're aware, but it's going on for many years. There are stone walls which are pretty, of a poor, I would say poor quality, but similar practice like the ones that we have seen in Nepal. So there is some similarity there. In terms of brick masonry, this is something that is similar to what we have here in older buildings in Vancouver and other cities in Canada. Mostly before 1980s, before the 1988 earthquake, they used only mud mortar for construction of brick masonry. It's very poor strength. And then after 1980s, they started using cement mortar, which makes the masonry stronger. Bricks were of all different kinds of shapes. Of course, as you know, so students at least know, and my colleagues, I'm interested in masonry, and it was like a museum for me to look at all kinds of shapes and the sizes of masonry of bricks. And I couldn't help it, but I took 3 of them to Vancouver. This is at BCIT, they're still in my office. And they are of very different. They would be not tested them yet, but some of them strength looks okay, but just visually some are poor strength. We could see damage to brick masonry buildings. Normally, these shear cracks, which are caused by just a lack of high earthquake intensity, and masonry is a brittle material if it is not reinforced, so that is no surprise. And in some other buildings, I believe this is a school building, you could see also cracks, which look very similar to the cracks that have been seen in experimental studies. So it's all seen and confirmed, so earthquakes confirm the experiments or vice versa. In any case, there was not too much surprises and what we have seen in those buildings. We have a number of buildings of that type in Vancouver, everywhere in Canada, and those buildings are vulnerable unless they're retrofitted. Luckily, some of them are retrofitted in Canada. Concrete block masonry, that is a not very common type of construction, as you could see them built, but there is a trend of using that in future. And there is a major concern because of the poor quality of blocks that we have seen. And again, this is one of the blocks, and with the help of my colleagues, I managed to get one of them here. And what we could see is that if they had a brick masonry building, they're doing extension, they're building blocks. Also, there is a tendency or this trend that we have heard that they may replace stone masonry with blocks. And the reason is that in those areas where they don't have, building materials, they could bring some cement, set up some homemade plants, small facilities, and make block masonry, and that could be really dangerous. So, anyways, that is what we have seen. So this is more or less very, very briefly about performance of masonry buildings, and this is mostly housing that we have seen. Bishnu will be talking about schools, where we will see again some examples of masonry, and I'll talk a little bit about heritage buildings, and then after Bishnu for talking about concrete buildings. So heritage is a big aspect of Nepal. Nepal heritage is known worldwide. It is so well recognized that there are several UNESCO heritage sites in Nepal. It is a global heritage values. Many of these structures were completely destroyed in the earthquake. As you could see, around 3,000 were reported damage or collapsed, huge monetary loss, and it is, when we were there, we couldn't see a sign, so when the buildings were collapsed, they were able to check what was there and rebuild them in the same way. So what they will build will be something different, I think. Just a moment, oops. What is typical for Nepal, and I don't know how many of you have been in Nepal, there are typical squares in big cities, so like in Kathmandu Valley, there are 3 cities, Kathmandu, Patan, and Bhaktapur. They have those squares where you could see old palace and then some temples, and those are the heritage sites. So you can see in Kathmandu that square, which is called Durbar Square. You can see the blue, the pink squares or rectangles are showing complete collapse of those temples and buildings, and blue lines or blue areas are showing partial collapse. So overall, it looks like really a very, very damaged place, and I'll show you how it looked like. So this is a scene from the Durbar Square before and after in Kathmandu. So these were the top tourist attractions for Nepal. One of the 2 reasons people go to Nepal, I would say there are others for sure. One is to visit those sites, and the other is to do trekking. So this is Durbar Square, photographs that we took. You can see, simply you can see pedestal of the frame of the temple. The temple has gone. Many temples have gone. You can see tour lanes, so touring the collapse. They still have guided tours, but what to see. So, anyways, these are scenes also from the same place. This is all Kathmandu Durbar Square. Again, you can see that bricks have been dismantled and kept for rebuilding, but again, it has to be done in a certain way. This is a palace in the back, which is completely supported. This is the palace, one of the palaces in the Durbar Square. You can see lots of props. And however, they opened, when we were there, this was the first day that they opened it for tourists. So you could enter into the palace and pay. Also, you had to pay for some time it was free, but then after they charged. And however, what we have seen also business as usual. So see, this temple is supported, but they keep selling things under the props, so they just don't feel the life goes on. So, oops, I think that is the end. We have done some studies on temple. We are planning to do some analysis of a few temples where some site period measurements were taken. But I'm remove those slides for the brevity of this presentation.
Talking to the reinforced concrete buildings, that's a widely used construction these days. It was not, but after 1988 earthquake, as Svetlana mentioned, there is a notion that when it's a concrete, it's a mix of cement, mortar and all the water, then it makes a magic. It is a magic. But whether all those implication of those mix are there or not, they don't know. They just assume that whenever it's a concrete, it's done. That's what causes a lot of concern. And definitely here you can see, this is the residential area. You can see lots of reinforced concrete building. It's masonry. It looks like masonry, but then everywhere you can see here and there concrete frame. And that is not only for residential building, for major commercial and institutional buildings. They don't have steel buildings and other type of shear wall buildings, but basically reinforced concrete building with masonry infill. That is the most common one. And it's all shifted, and if we try to find a new purely masonry building, it is hard to find. It's all going to, this shift of construction is to reinforced concrete building with masonry infill. And when it comes to reinforced concrete buildings, they are typical like a 3-story building, it should be actually with the guidelines and codes, it should be 3-story building with a simple regular system, but now with the need, and they can go there, and they are going actually to 6 or 7-story, with same column size and same beam dimension that used to be for 3-story building. And when it comes to seismic detailings and others, yes, we will discuss. That's the major factor. What we have seen in Kathmandu, that some of the buildings we have seen when we go from airport to the hotel, there are not much damage. Okay, we have seen that buildings are standing there, fine. And all of a sudden there is all pancaked building. And then again on another block, there is one building going to be pancaked. And it's a really interesting to see that, to go through that observation, why that caused that kind of situation. Actually, I didn't have much time to talk about the motion, but the real motion, acceleration motion that we talk a lot when it comes to force, that's very low. It's just 15% of G, or with the design code value, it's just 1/3 of value. That means with that 0.15 of G, there shouldn't be any damage to reinforced concrete building. But then there is a damage, but then there are also no damage. That means why that happened? It's basically culprit is the detailing, and also culprit is the wall, the masonry wall, which is not actually regarded or not considered in the original design and construction as to work as a shear wall, but it works that way. So when it comes to proper detailing, proper seismic detailing, as we know, what are all these ductile detailing things for earthquake resistant system, and then frame buildings should behave like this, and it goes large deflection is still standing, it has reserve capacity and everything. But when it comes to those construction in Nepal, that is basically all of a sudden here you can see that those buildings are surviving, one is going down. What happens is that it has a threshold value. Up to that threshold value going that, there is nothing, we cannot see much. But once it reaches there is no reserve capacity. It's a brittle failure and it's just gone. And that is a lack of lateral load capacity. That is, once up to that point they stand, and that is all due to the fact that they have a wall, which is not considered in design, but thankfully that protected lots of building, and because earthquake is low. But still some buildings surpassed that load because they constructed 5th story, 6th story, and that all of a sudden it goes. And then another factor is irregularity, and again that is because of the wall. They put wall in a regular fashion, okay, it's a fine. But when it comes to wall with this kind of building with the storefront, you can see that all the storefront, the retail store, they don't have any wall. But for engineers, for construction, okay, that's a frame building, why should I put a wall? And that's a common thing to have a consideration from engineer's point of view. But that's where it's all culprit there, that avoidance of that wall there you can see. And particularly in this earthquake, particularly hard hit are these kind of buildings where two side open and two side blind. So what happens is in earthquake, it's all with the two side having their standing, it just twisted. And also, because the wall is absent in two sides, then obviously the capacity to resist the whole 3 or 4 story, 5 story building is not enough. And that's where we couldn't see, there are lots of buildings like this there, but then all of those buildings are completely collapsed. And it is a simple phenomenon, it's called soft story, and that first story, it's weak for different, for a number of reasons, and one reason is absence of wall, because wall is, acted jointly with the frame in that system, and it is now absent, and that's where it overstress the particular column that without wall, and then that goes pancake collapse. And that is what happened here in these buildings in two sides, and this side going this side and that side, and that's where it could not resist and it just pancaked. And in many of those buildings, even we did not see any damage distribution in the upper story, just the first floor, just pancake, and that's it. That's a very common phenomenon. And when it comes to high-rise buildings, medium-rise buildings are up to 15-story high, not very common, but it's recently just last decade they're grooming a lot there, popping up everywhere in the city, and there is no collapse, but there is a huge damage. We cannot see much from here, but if we look closely, then there is a huge damage, non-structural damage. Again, those unreinforced masonry infill is not able to handle it, those large displacement coming from those from that earthquake, and which is, again, that earthquake is very unique. It has a very low acceleration, but it has a very high velocity and displacement, which is detrimental to those kind of walls and high-story building, because displacement demand is very high. So you can see the close-up there. It is not usable anyway. So those high-rise buildings. And when it comes to school building, that is where we included school building because it's a hardest hit. And in those districts, it's the hardest hit districts in Nepal, Dolakha. In some districts, 100% is school collapsed. No schools there. So it's a huge loss. And I have been working on this field in protecting school buildings in Nepal and other countries in Asia Pacific. Also, I have a chance to work on the school building guideline here in BC also. And that's where I spent my time later after this mission is over, almost 2 months, going to school by schools and look what we can do. And the school is also a means to provide a different structure or the technology if we can provide to the community, because there is no formal mechanism of technology transformation to the community. That's where only school is the one network that we can use that one. That's where I use there. But then when it comes to the school, the 30,000 classrooms completely collapsed, and 870,000 children out of school. It's a huge impact to the country. And most collapse of buildings are from masonry, but some nice looking reinforced concrete building with a nice painted everything looks good, but they also have a pancake. And then for the same reason that I mentioned for the reinforced concrete building. And those are mostly done by foreign NGOs. But then again, with the lack of technical oversight and proper design without consideration of the seismic hazard, the result is that one. And this is one of the collapsed building in Kathmandu. It has, again, you can see immediately that there is a soft story collapse, and the result, soft story problem, and result is this. And it houses 900 students, and luckily it is Saturday. Otherwise, all of those 900 kids will be under the rubble. So that is the gravity. The problem. And the status of the current status of the schools are more than 4,600 temporary learning centers established, and 1.5 million children are provided essential teaching and learning supplies from the outside. And so many teachers are there, and first, definitely for the psycho support. That is what the most needed one. That is when we were there. And the situation is like that. They are still, in the heart, and then still trying to go with the life as usual, but definitely it's not. And when it comes to the focus study for school damage, I went there in a number of villages, number of districts there to do a damage assessment, proper physical damage assessment, and also I tried to interact with the local technicians, local carpenters, masons, and also the teachers and community as a whole to understand not only about the damage itself, but how can we rebuild the things, and what is the best way to have a better technology for the reconstruction of the schools. And that is where the group meetings and this is with the principals and teachers. And with the damage assessment part, yes, the finding is that the retrofitted schools with the simple measures, or the schools which are designed properly with the simple measures, the bands and others, they work perfectly. And this school here, here in the corner here, that is just next to those Adobe buildings, and that building was retrofitted one. It's Adobe building retrofitted that survived without no single crack. It's wonderful to see that. And this building here, it was in the village of Rashua, where only this building is stand out in the whole village. And that was earthquake resistant with its, having a bands and reinforcement. And that's the only building in a whole village. So those are the situation there. And talking about that building, I want to go a little bit more because that I was in charge of that retrofitting design and construction back in 2000. And the first thing, actually, that Saturday, I called to the villagers there and then asked what happened to that school, because it was right in the middle of the Adobe construction, and it was Adobe construction, and we challenged that, okay, we can do retrofitting also for Adobe construction. And it went well, and no cracks. So that means, and that school was the first school actually retrofitted back in 2000, and that school was not only first in Nepal and in the whole Asia, that the school retrofitting program started with that school there. And the technology is very simple. You can see that the simple jacketing from inside and outside with the mesh and micro concrete, and put all the anchors inside and out with the spacing, staggered spacing, and put with the plaster inside out, and then change the diaphragm, flexible diaphragm with the small concrete topping with the rigid one. That's it, and that worked well. And does that mean that simple technology, or whenever it's just a name in the name of retrofitting, everything works? Does not work. Look at this one. This is before. This is done one of the major INGO, I would not name it, major INGO from US, doing a lot of school construction all over the world, and they did that retrofit there, and the consequence is this is before and this is after. It's completely flattened. And simple reason, there is no technical oversight. One engineer just to give a design and ask, on trained masons, okay, to implement that retrofitting, which is a complex. Design is not that simple. And construction is more, because earthquake even does not recognize design, it recognizes only construction. Where it should, we should have proper training, capacity building, and oversight. And you can see that corner there, that corner, it looks like, it looks like this one just peeled off. All the reinforcement bar that was provided there just peeled off. Where is retrofitting? How that force is transmitted to that reinforcement? Nothing there. So we put that report out. It's already out. That report together with professor from Western Washington University and one colleague from US. It's out, and it shows the strength of retrofitting and some weaknesses, some lapses. What happened with that program of retrofitting that has already retrofitted 300 school buildings in Nepal, and which has some relations for us to where we are also under the retrofitting program here. And when it comes to building demolition, when we are there, it is a demolition and construction. Deconstruction was started there, and the demolition is particularly hard for the reinforced concrete building because there is no mechanized system and there is no equipment. So people doing manually by hand all the demolition of the concrete building slabs, reinforcement column, and everything. And that was hard to see. You can see some of the demolition there, and they are using those material for the reconstruction. They are already keeping that. So it's not just a demolition; it's a deconstruction for reconstruction. Right? They are keeping those material there. You can see that is a school building again, and that is what the manually they are doing hammering up. It was challenging, and they are keeping those material in the safe place so that when reconstruction comes, they can use it. And when it comes to the reconstruction, it's a huge task there. International community plays almost $4.5 billion funding for reconstruction program. Major focus is housing construction. That is where most of the damage is. It's not much on the infrastructure, but mostly in housing. And the goal is obviously not just to building back, same thing, but building back better, BBB, right? And that's where the whole capacity building is necessary, because it is not a simple task of going there and then again handing the good drawings. It's more than that. It's all about the capacity building of who really implements it. And Reconstruction Authority was established there, and that embraces a community-driven reconstruction with the necessary financial and technical assistance. That is to do with the involvement of people themselves in the whole process. And because it's not like our society that engineers or the contractors do everything. Basically, all those buildings are built by owners, so it's an owner-built system. They manage everything, including configuration of the building. They get little bit technical assistance from masons and carpenters, or maybe maximum by technologists. The rest they do by themselves. So there should be capacity building awareness to that level. And obviously, when it comes to the whole reconstruction, they have good thing. Also, we discuss about the mutual help, cooperations, and all the resiliency. But that does not help by itself. They need some resource. They have a constraint. So, and that resource is not the financial resource, but the technical capacity building. That's where I think the community that we are here, we can offer to that. To that end, whatever comes to raise the capacity, so that it, that I mentioned there's a big seismic gap waiting already for 600 years to have a major earthquake of more than 8 magnitude. At that time, the reconstruction goal should be to gear whole reconstruction as a practice, so that this disaster never happen again, even if big magnitude earthquake hit there. With that much, I want to acknowledge the kind support from, or the initiation from Canadian Association for Earthquake Engineering, and support from School of Construction and Environment at BCIT to have this mission. Thank you so much.